Hello everybody, welcome. Okay, so hello everybody, welcome. My name is Kilon Alios, and this is Ephestos. We're working on a procedural generation game. As always, we are here to investigate everything that is needed to be investigated for creating procedural games. In the previous stream, we worked with trying to embed Python inside Godot. We actually were successful, believe it or not. And today, I would like, actually, when I added the stream, because I was battling with Python paths, I managed to do something. First of all, we have found out that this is the paths we need. This is two paths. The first one, because we need two things, first of all. We need, first of all, the Python DLL, or as it's known in Linux as libpython, I think it's called libpython, libpython, I think something like 3.11.01 so something like that. So basically it's the same thing, it's a DLL. Basically this is the thing that our executable, our Godot executable is going to load in order to be able to trigger Python. This is where the low-level functionality of Python is hidden. As we said, Python is written 50% in C and another 50% of the CPython implementation is in Python. So it needs to find, first of all, the compiled C code for the Python source code, which is inside this DLL or this SO, or for macOS will be a dilib. So but I'm not going to be supporting macOS in this case. Probably I will not really working on macOS at all. And then we have to find also where the other modules reside. So first of all, we need the standard library of Python, which has all the modules, and this is where it says us where to find this library, which is, in this case, this path here. Now, this is not ideal, and it's not ideal because it's an absolute path. So, what I want to do is move everything inside the prepackaged thing we have done for Python. So let me close that, we don't need that. So, okay, what is that? No, let's start closing here, some things. Not too many things open as always. Do I need all those things? Okay, let's keep only those. I don't think I need anything of those. So what I've done yesterday, because believe it or not, even though I stream for 7 hours, I work another 1 or 2 hours on paths, because I wanted to see what experiment to play around with. And what I did was create this kind of SH file, which basically is a Linux bash file. It's a command line script in essence, so you can have command line scripts in Linux, which are usually called bash files, or you can have or shell scripts they're called usually. Or you can have also command line scripts in Windows. Usually they are called BAT files, the .bat extension, or I think it's called also PS files, which is the PowerScript for those that are using PowerScript. So you can load things from the command line, and the nice thing about this is that they can do things like this. They can, of course, launch the executable, as we used to say, and we want to launch from the command line because usually we print on the command line. And here you can see I fix the command. So here we see, so what I'm going to do here is the following. So let's fix the paths a bit to make everything really fine. So what I'm going to do is going to go in this directory I have. So actually, let's go coding. Let's go. So CycloPython is basically my Python that I'm using. And inside here, I have also installed scones. So now actually, if I enable this, no longer really disrupts my scones work. Okay, sorry, they don't see that. So no longer it disrupts my scones workflow. If you remember last time I had to change back the exit terminal and go back to it. So now I fixed that. I have installed scones inside here, and of course the side packages are the ones that contain all the libraries that we are using. So we need this, and I'm gonna need the entire folder here. So what I'm gonna do is the one thing I have. So basically what I need here is there are two libraries. The first one are what's called side packages, which is a library folder that contains all the third-party libraries we install, like scones or like pip, etc., which are not part of the standard library of Python. And then there is the standard library, which is basically the library that is included with Python. Yeah, of course we have a spam bot. Let me ban this guy. Actually, let me fix that a bit. Now that I'm talking about spam, let's fix it one for all and start banning anyone that has this kind, because I think they all use the same text. So let me change the text. Give me a second to see where spam protection I think was. Yeah, so options. What is that? Oh, here it is. Okay, so let me change that. Okay, so let's see what you say. When it becomes famous. Okay, so how the hell do I put an entire string there? This is the field listing of the words and phrases you want to block. Enter one entry per line. You can use an asterisk as a wild character to delimit the chart. Okay, let me give me 1 second to find what he says. Okay, let's copy that then. Yeah. Okay, I'm gonna have to ban this. Sorry, guys. Yeah, I don't know. Why doesn't it have it bigger? Enter one entry per line. Okay, let's see if this works. Let's copy the entire text here. Let's see if that's gonna. I don't think that's gonna work. Submit. Okay. Well, maybe it will work, maybe it will not work. One entry per line. I don't know if this is gonna work. Anyway, hopefully I'm not gonna spam I don't know. I don't trust it. I don't trust it. Okay, so let's put that then. Copy link. Let's put that maybe. Submit. Okay. So actually, let me do that. Sorry about this, guys, but I want to fix the. So ban this guy. He is ES. Yeah, ban this guy. Okay, he's banned. So, as I was saying, before I was rudely interrupted by the spam bot, what I was saying, yeah, so we have to fix the paths here. The big question is how to do this. So what I can do here, 311, have one that says standard library. So let's do that like that. So let's create a new folder here that says std.lib, which stands for standard library for Python. And I think, however, there is. Okay, let's go change that to just in order to confuse it with that. Let's change this to Python standard library. Okay, so I'm going to actually put everything that I. So okay, no. Lib Python 3.1. So let me open a new tab. First, let's go, guys, see if you've seen this. And I'm gonna go now into my Python folders, the compiled Python I have here, and I'm gonna copy this, everything that is inside here, because what is inside here is basically the standard library. Control F3, Control Copy. I'm gonna go through here in PyStyle.lib and paste everything here. So now I know that everything is inside lib, Cyclops Python lib, blah 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 blah. So another thing I need to do also is to copy the DLL itself. Now the DLL itself, I will put it inside the binary folder, which is the executable of Python. We don't really need the executable of Python, but I'm gonna keep it anyway. I don't think it's really, so this one has executable of Python here, which is only, is it really so small? Only the F7? Oh no, that's actually shortcuts. Ah, those are shortcuts. Link to home keylon coding C Python. Ah, I create shortcuts. That's interesting. So I need to copy here the libpython. So, okay, so what I'm gonna do, I'm gonna leave here and go to CPython, and only thing I need is this one. So I'm gonna save that. So actually she creates shortcuts. Interesting. How the hell creates the shortcuts though? I think, actually, yeah, we executed because we executed the swinging path. Okay, so it creates only shortcuts. Interesting. Okay, so I'm gonna go now to Cycles Python. I'm gonna bin, and inside here I'm gonna put my ASO, which is what I need. So what I'm gonna do then, I'm gonna take this Cycles Python, and as a matter of fact, let me rename that to something a bit more. Well, Cycles Python is not bad. Yeah, okay, let's keep it as it is. So I'm going to take this, copy this, and then I go inside the Godot build folder that I have built Godot. And I'm gonna go to Cyclops. And I'm gonna go to the bin folder, which is the build folder. And inside here, I'm gonna paste. So as you can see, I tried to paste in together inside this folder, but I didn't find it. So move to trash. And now I'm gonna edit this one and say, instead of going like that, instead go inside here and find the library path in Cyclops Python. So this one is where to find the DLL. Cyclops Python bin. So this one is gonna be in the bin. And the Python path now is gonna be in, again, Cyclops Python. And in this time will be in Cyclops Python, I think was in lib Python 3.11, and of course by studio standard lib. So that will give me the Python standard lib, which is nice. So that should work now. So if I go now in my terminal, go to the terminal and go cd Cyclops, which is basically my, it's coding Cyclops, bin. And now I try to execute this script, Cyclops SA. It should work without any problems. So what happens in this case, let's see if everything works fine first of all. What happened? Why doesn't open the window? Ah, okay. It cannot open. Why? Okay, let's take a look at it again. So here's the bin folder, Cyclops. The bin has in limpython 3.11 so10 here. Okay, and Cyclops Python lib, right? This is the Cyclops Python bin. Cyclops Python bin. So why the hell cannot find the 3.11 SO? Why you make my life so hard running? So it seems that I cannot find the show. Why? I put the path here. Oh my god. Okay, so bash script get current path. Okay, let's take a look at this. Actually, let me... Yeah, how do you get the current path in bash script? Okay, okay, let's take a look at this. Blah blah blah. What? Seriously? I want to use a bash script as a launcher for another application. I want to change the directory to one where the bash script is located, so I can operate on the files on the directory like so. It's useful one-liner which will give you the full directory name of the script, no matter where it is being called from. What? Why we need all these things? Must be an easy solution. Dir name. Okay, let me change that. Because obviously the bash script doesn't work the way I want it to work. Okay, let's close that. Let's go back to the script and let's okay, let's try this. Let's try this. Copy. So let's go over here, remove the bin bash, and let's see what happens. Okay. So let's take a look at this. Yeah. The script you're running has base name Cyclops SH, their name. The present working directory is home. Okay, so this is what I want. So how you get this? You get this pwd. Okay, let's echo off. I think it's echo off, right? Is it echo? Is it echo off? Ah, echo on, sorry, echo on. Right? Is it this? I don't remember. Okay, let's... I want to see and print the paths that I'm passing there. Because right now, I use the PWD, but I want to see exactly the paths that are gonna pass in. So let's take a look at bus echo on. Okay. Blah 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 blah. What? No, I don't want that. Set X. Okay, set X. Okay, let's go set X then. Let me close that. Okay, so and close that. So base name, how close say it's dealer name. What? Okay, so is this gonna work? PWD. No, that's right, actually is back quad. Let's take a look at this. Let's take a look at this. Wait. This is what I want. Home Kilon. Yeah, yes. Home Kilon coding. Kilon coding Kyclops bin. Yeah, that's correct. Wait, those are correct paths. Why I cannot find the... What the hell? Wait. Why I cannot find the path then? So now I cannot find, okay. So I can launch the DLL here, but I cannot find, I cannot find the encoding. So that means it doesn't find the library. So this one is gonna be also, let's remove that. So what I'm doing here, I'm passing the standard directory that the script runs from. I don't know if that's the best way to do it, but it should work. Let's see now. Yeah, it works. So now it works, everything's fine. So actually that was it. So let's take a look at this, right? So what I did, what the hell, what is, okay. What I did, okay, let me tell you what I did here. I did the following. So I basically copy-paste a folder that has all the, all the requirements. So inside here has the lib Python, which I need to execute Python, to be able to run its code in essence, to run the Python code interpreter. And then here I added inside 311 the side packages, which is of course are the third-party libraries I'm using, like scones. And then also the standard library of Python that actually passed here. Now, the one thing we need to do additionally is also pass the path of where the module is going to run. So probably I will add another library here, which is going to be the Cyclops API, the Cyclops scripting API. So it's going to be another folder here. Or I can put that inside the standard library, but I don't want to mix things in the standard library with this weight because I want to keep things clean. And I don't want to put it inside the side packages here. I want to keep a third library here, a third folder that's going to be a scripting API in essence. So the paths, I think, are resolved. This is actually, it solves the whole problem of the paths. So now this script basically tells it exactly, and let me remove that. Let me remove also this, they're not needed, and also these are not needed as well. So only we need this. Okay, let me close that again. And if I go and do that again, so that's it, runs fine. And if I go here, I don't see any errors. Now you may find here an error that says home kilon blah blah blah. This is an error I actually output because I wanted to print the paths of that are posted in the system. So this is basically, I think this one is the system path if I'm not mistaken. Wait, do you don't have also a print of the system path? No, this is the system path. So this system path is the PyST library. And also these paths here that are not really serving anything. I don't know exactly what they mean. But right now, it only points to its standard library. And I want also to add the library for loading the Python modules. So that's only the problem I have right now. You need to have another library here. And another thing, one other thing that it misses here is that it doesn't point also to the side packages, which are located inside here. So this is where it has to point in this directory to find all the libraries that are used by as third-party libraries. So this is actually enveloped. It needs more information here because I think every time it imports a module, goes to Python and imports module. So Python import import path. Let's say import path because I think the information of import path is here. The import system. No, don't do that. So the import system is here of Python. So any time it imports a module, it goes through a specific path. How is the path? Where's the path exactly? Searching. They begin the search needs the fully qualified name of the module. And this name may come from various arguments to the operator statement. It doesn't say. It says for 6 modules. Case of all modules I have been loaded. So if one was previously imported, this module will then. So it says that it continues to search for the module, but where? Where it searches? Import path. So the import path is a list of path entries. Yeah, comes from the sys path. So the system path basically points to the where to find. So Python needs to know where to find modules, whether they are standard library modules or they are external modules or they are whatever other modules. It has to have some paths to find those modules. So in order to do that, we have a function here which is called setPath. I don't think I'm using it. So there is a set path function. So I'm using the get path, which returns me here. So let me take a look at get path. Get path returns me this homeculon, which is the pystilib, levenship, and dlog, which is the same thing as the syspath here. So I think that separates by, yeah, it's separated by those things here. So the big question now is how on earth we're gonna construct this path. Okay, let me think about this. Because I think this one also is fed by the Python path. Okay, let's think about this. Python path is the main way to find okay. So echo Python path. So this is the Python path sets. I don't want to send it permanently because I don't want to mess with the. So basically, the nice thing about running a script is that every time we run the script in bin, okay, let me actually copy paste that, make sure that I synchronize it with a script that I have inside here. Right. So every time this runs is going to create those paths are going to be created only for the running of the script. They're not going to be created for anything else. So that means that when he executes again, it's going to still reset the paths to where they were. But how do I add paths to the Python path? That is one thing I don't really know. Okay. Can I have multiple paths for the Python path? Can I have multiple paths for Python path? Or it's gonna freak out. So multiple folders, okay. So how can I set that? Is it possible, first of all? Okay, it uses this. Yeah, okay, so it uses the... Right, so that's what I want to do. That's perfect, that's exactly what I want to do. So what I'm going to do here is I'm going to go to Python, and now we have... Where am I? Okay, so I need to create a new folder where I'm going to put my API inside here. So here it's going to have the Kickloops Python API. So how do I name this? So create folder. Let's call it Kickloops Python API to keep this everything clean. So inside here, I'm going to put in all the modules that I need to run for my engine, the Python modules. So I have to add this to the path. So what I'm going to do, I'm going to go here, and instead of passing one thing only, I will say this one additionally with this one. So it separates the paths using this key argument here. And the nice thing about having this script is that you cannot run this script on Windows. So there's no way that it's actually going to mess up paths in any way. Kickloops Python API is here. So save that. And I also have to make sure that this is on the bin folder as well. So if we go to the bin, which one is the bin? This one is the bin. Okay, let's go back to, I forgot to, okay, let's copy paste the entire thing just for no wasting time. And where was it? It was here. So now we have a multiple paths. We can keep adding paths here for wherever we put our Python modules. So that solves the problem when it comes to the module. So we're going to have now a structure that basically is going to be Python library, which has all the libraries of Python, anything that Python loads into the module. Python 3.11, which basically I find unnecessary, but it is supposed to be for when you have multiple installs of Python. And there we have the standard library, which is here. We have the third-party libraries, which are inside side packages. And then we have the Cyclops Python API, which is, of course, the modules we define for interfacing with Cyclops using Python. So this is where we're going to put modules. And inside here, I'm going to actually make a module. And I'm going to name this module. The only problem with that, with this kind of idea is, actually let's put it inside here and let's go and paste that here. So new folder, no, actually no, not new folder, sorry, my bad. In Cyclops, new folder, and this is gonna call Cyclops Python API, which we can actually copy paste then to put anything here. So what I'm gonna do inside here, I'm gonna go and open Cyclops against CPP, and I'm gonna go and take all this, remove it. Actually, let me not remove it, actually. Let's comment it out. And what I'm going to do is copy that and yeah, and copy that and go into the Cyclops API, make a new file here. I'm gonna call it test code PI. So I'm gonna just for testing. And what I'm gonna paste the code here. But because now this one is Python, we don't need the zip code anymore. So we have to make everything Python. So what we do, we're gonna execute the same exact code, but we're not gonna need, of course, Python. And let's import sys. Yeah, I'm fine. I import sys 2 times. Okay, we don't need that. And let's, of course, remove those and those. Yes, 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 and yes. So now that's a Python file, Control X. Let's make the imports up there. And now we also want to do what? What I wanted to do with this file. I want to, yeah, and make another print that says print. Yes, this is an imported module in Godot. Python module in Godot. Okay? So now we will have to ask ourselves, how the hell we are gonna import a module and execute it? Now the way to do this, wait, what? It's a multiple lines, okay. So the way to do this is, I think, can be found in embedding Python. I think they had an example there of executing a module. So embedding Python. I don't care about Linux anymore. So embedding Python is gonna be, I think the module was here. So where exactly is that module? Okay, let me think. I don't think we need to do anything specific for the module, I think. So this one is, let me think. Module is not new, so PyImport module. And what it tries to do, I think it tries to get a function. Right, so we don't need to do anything. I think that it's just doing that pname. What's the pname? PyObject. Okay, PyObject pname. No, we don't need any of those. We only need the PyModule. So let's do that. Wait, why doesn't it copy paste? So copy paste that. Actually, I don't need that. I can actually do it myself. It needs only PyObject pointer. Okay, that's fine. That should work. So what I'm going to do is say Python. Python by PyObject, by the way, is how Python describes py module. And the py name here we have is gonna be, I don't know if you can pass it a string though. Yeah, I may not be able to pass the string. Well, let's try it. It's gonna code, I think it's test code. I don't think you need to pass the PI extension, it's implied. Let's see if that's gonna work. I don't think it's gonna work because, yeah, it's gonna complain. What? No. Is that the problem? Yeah, okay, let's try compile this and build this. Let me go here. Let me close this. Yeah. And let me go outside. Is cons here available? It should be available somewhere here. Okay, here it is. So let's take a look whether it first of all builds without a problem. We have some problems here. So it says here, initialized argument, but okay, we have an error here. Cannot convert construct object to py object. Okay, so we have to change that then. So what we're gonna do, we have to make the name. We have to actually make the name after all. Okay, so we're gonna have to have a py object p name. Yeah. Yeah, you have. Yeah, because the reason why we have to do this is because Python uses Unicode only, so it's not gonna like this. So let me see how to do this. So instead of p name being here, argument blah blah blah, what we're gonna do is we're gonna go and say. Paste, and this one is the F argument 0 is gonna be test code, right? Yeah, test code. And we're gonna pass the p name instead. P name. Okay. So now it's built without any issues. Unused p module. Yeah, we can just create a pointer to the module in case we need it. I think importing should be enough to execute it. And of course, what we have to do as well is, what is that? Yeah, so we have to leave here. This is the Cyclos API, right? Yeah. So we have to leave here, and we have to go to. Yeah, we have to go, of course, to the modules, Cyclops. Where's Cyclops? Cyclops, and go to Cyclops Python API, and of course, copy that. Copy that to the Cyclops. Wait, what? Yeah, to the Cyclops. Wait, what? No, I'm confused now. Where am I? Yeah, inside the module, so okay, let me. Yeah. That happens when you mess with too many libraries. So I have to call Cyclops bin, Cyclops Python, lib, Python 3.11, Cyclops Python API, and paste it here. So you can execute the code. And now if I go here, it should work without any problems. It has two nodes and one, it's not a problem. And let's go to the bin, and then run the Cyclops sh. So now it should work, and if we run this, it should work, maybe. Okay, it seems to work, but let's make sure that happens. Yeah, so that's it. We accomplished that. We can now load modules, and instead of trying to compile new SQL every single time, now we can run our code from a module. So that fixes also that. However, we can change this, and we can change this by passing a module name that we want to execute, although probably I will have a main module going to be executed anyway. So now the big question is there anything I want to do with So basically, I accomplished now my goal of having a module here, and the only thing I need to do right now is that. So, for example, if I go to, let me open the bin folder to edit the module from inside there, because I don't want to build it every single time. If I go inside the lib and go inside the Python API and open the test code, yes, this is important module Python code in Godot. Yes, this is. Now let's make that to, this is a modified import in Python module in Godot. So as you can see now, if I go to text, it says, yes, it's important Python module in Godot. If I close this and re-execute, so I go back here and re-execute, I can go here and say, where is it? Command line. This is a modified important Python module in Godot. So as you can see now, we don't need to rebuild or code and rebuild everything because obviously it's not practical. Now we can go and directly change the Python code, and all you have to do is to relaunch our project. And even that will not be necessary in the future because I will import the PyLive coding library I have, which will allow us to reload modules dynamically, real time, and change our code while the application runs. Which is now, of course, in order to run modified Python code, we have to reload the module. We have to re-execute. So in the future, we'll be able to modify source code the same way you can do with JavaScript. I think JavaScript, if you modify JavaScript, is going to update it on the executable while it runs. And in this case, this runs not only with the editor, but it's actually going to work even with a game. So if you go in the game and change the script file, it's going to update it real time in the game as well, which I think that is not a feature of Godot, by the way. So this is something we're going to be doing that is going to be better than Godot. So ladies and gentlemen, I'm happy to announce that we accomplished our goal. We have a Python module inside there. We execute arbitrary Python code from inside Godot, and everything works fine. The syspath, as we see, has been working also fine. So we have here the PyStandard library. We have here the Python API, the path for the Python API. So we have all that, but we also need to add the path for the side packages. That is one thing I forgot to do. So all we have to do that is change that into, where is that? We have to change the sh file, which is this one. So we have to add here also the side packages. So let me go here and add another path which is going to find us, because otherwise we will not be able to import the side packages. So it's side. Is it side? Let me see. So this is the Python API. So the side packages are here, side packages. So yes, we are successful. We have Python fully integrated with Godot. We can run Python modules. We can even execute our code from inside the game without having to go through the editor. So the editor is completely optional here. It's not really necessary for working Python. However, there is a big disadvantage, and the disadvantage is that we don't have access to the Python internals from Python yet, to the Godot internals from Python yet, right? So we have to fix that. But of course, this is the big, this is the big task, right? How to expose Godot internals to Python. Hey Kilon, you are streaming early. Actually, no, this is the time that I always stream. I usually stream this time. Yeah, I'm streaming for an hour now. So yeah, this is actually more or less me being on time. You make this look like you are doing full-time game dev. Yeah, I'm actually doing full-time game dev. Because I've been... yesterday I streamed for 7 hours, for example. So yeah, this is full time, definitely. 7 hours and another 2 hours of work that was off stream. Congrats on the Python integration. Thank you very much. Yeah, I'm pretty happy with this too as well. Running Python is really amazing. right? Be able to just trigger that, and having code running inside Godot from Python is gonna be a life changer for me. Let's take a look at this. Okay, so let's make sure also that side packages are loaded as well. Thank you, man. Welcome to the stream. How you doing? How's your process going? Okay, so let's take a look. Also, the paths are all working. So we can load our modules. And as a matter of fact, what we're gonna do is go and import such a module. Okay, let's take a look at terminal again. So is the side packages here? Wait, what? I think I changed the wrong SH, right? Which one is this? This one is? Yeah, I see this one is inside modules. Okay, let's copy that and go to this one, which is in bin. Change that, so now it should work. No need to expose the Godot internals to Python now. Now you can import the data stuff in Python and pass it to GDScript. You pass it to GDScript. You need to expose the Godot internals to pass the things to GDScript though. That's the trick. I mean, you can, of course, but you still need to build the functionality to do that. So it's not difficult to do it. If you have like a Python, so for example, yeah, I mean, how you read the Python dictionary, for example, is very important, right? So you have to make some kind of class that allows you to convert a Python dictionary to a GDScript dictionary, because they're going to be two different things. Now, if you're talking about simple strings, yeah, that's going to be super easy. If you're talking about simple values, yeah, you can pass those to GDScript easily. But you have to write C++ code that will make this conversion. So we haven't really yet worked on converting things to GDScript. And as a matter of fact, I will not be working with GDScript at all. The implementation I'm making right now is going to be mostly Python. I don't think I will be using GDScript. I'm using GDScript right now to just launch Python, and that's about it. I don't plan to use GDScript at all in my project. It's going to be 50% from the looks, from what I'm looking at, it's going to be 50%, maybe 30%, 20-30% compute shaders, another 30% C++, and a 50% Python. I'm planning on reorganizing and improving all my procedure generation code this evening. I want to be able to generate more consistent, high-quality stealth level every time I hit the play button. Stealth level. Then I can release the full game with infinite levels. More consistent, high-quality stealth level. What do you mean by high-quality stealth levels? What you're planning to do exactly? Procedure generation. As a matter of fact, you may be happy to learn we're going to go back to procedure generation right now. So Python is finished for now because I don't have anything right now to work Python-wise. Because the focus of the project, we switch back to what is important. And what's important for me right now is procedure generation, as Sierra said, for his own game. And I will be working, and we'll be going back to marching cubes. So that's it. Python-wise, let's get ready for marching cubes, because we're gonna go back now and work on an array generator. Because that's the whole deal there, right? So the whole deal is how to expose all those functionality to Python. But in order to expose this functionality to Python, we have first to implement the functionality. My game can generate cities using binary space partitioning. So level is split up in various size partitioning. Yeah, I remember about binary space partitioning. This was great. Okay, so you still haven't told me what you mean by high quality. Hello today, how it's going? Hello there, Fahrenheit. How you doing? What time is it there for you? Let's see, Canada time. Canada time. Is there such a thing as a Canada time? Canada time. Oh, 5 a.m. Wow. You're still awake? 5 a.m. Wow. It's 12:20 here. So it's actually noon here. It can also generate rooms and decorate them for various purposes like a bed. It's 2:20. Okay, so it's much earlier. Okay. So you guys have a big country, so you're occupied pretty much. It's a Vancouver kind of thing. Okay, so 2:20. Nice. You can also generate rooms and decorate them for various purposes like a bedroom, dining room, and so on. This works great, but the building generator is supposed to fill each city partition with as many rooms as possible, and this part of the generator fails. Sometimes the partition remains half empty. So I need to figure out how it goes wrong and fix this. Okay, I see. So you make a procedural level generation, and you use binary partitioning to partition things into halves, in essence, and break those things to other halves, etc., etc. And then you want to make this fill the entire level, in essence. So it doesn't fill the entire level. Okay, I see now. What are you going with this? Okay. Right. Well, yeah, there's always problems when it comes to coding, that's true. So, okay, so I finished with Python. It's fully integrated with Godot right now, which means it runs from inside Godot. It's not yet I have access to the Godot internals, but that's fine. We are not in an impasse. And we're gonna go and work with the terrain generation, which of course is the matching cubes. So let's go back to the matching cubes. What was the matching cubes? Here. So let's take a look at what happens with the matching cubes. So right now I have the matching cubes here, which don't create any errors, right? Kind of surprised that it works. So we have here the tree mesh, which describes the triangular mesh, which has only 3 indexes, which is the 3 vertices that make a triangle. So this is the first vertex, the second, and the third vertex, and all 3 make a 1 triangle. D-word, it has been assigned as assigned long, D-word. And we have here the grid, which is the voxel. So basically I have to visit Greece one day to honor my family. Yeah. With a sacrifice to the Temple of Zeus, yeah. Yeah, I mean, you should definitely visit Greece. Yeah, it's a beautiful country, and I'm sure you're gonna love it, especially during the summer. But even during the winter, Greece can be quite beautiful, up to the mountains, the snowy mountains. So yeah, definitely I hope one day you're able to visit. Although it's quite a travel, it must be like a 10-hour flight? Quite a long flight from Canada, if not more. The greatest challenge with procedural generation is maintaining constant quality depending on the amount of freedom you give the procedural algorithm. Less freedom means easier quality control. Maintaining consistent quality depending on the amount of freedom you give the procedural algorithms. So what you mean by giving freedom to the algorithms? You mean you don't control the generation so much? Yeah, of course, yeah, you're right, of course, yeah. You have to, when you make procedural generation, basic procedural generation, for those that don't really know, it's nothing more than throwing dices. Like to throw dices. So what you do when you want to control the procedural generation, say that I'm not going to accept values that are beyond that. So if you want to have a dice that throws a 1 and a 6, you say I'm going to reject any other value. Because for me the best values are 1 and 6. But you still do not really know when it's going to throw 1 and you still don't know when it's going to throw 6. So that's basically how the procedural generation works. You have to create a rule set that controls how things behave and how things are created with procedural generation. That is true, yes. I bet your windows are much better than ours. I don't think so. You guys get a lot of snow. I mean, we get snow as well, but you have to leave Athens. I mean, yeah, we get snow. But we don't have, for those that want to ski, for example, we do have one ski resort, which is pretty big, but is nowhere near as big as the big ski resorts in Alps. In Europe, and I assume Canada also going to have some kind of very huge ski resorts there. because of the mountains. You guys have a lot, very large mountains. But yeah, I mean, it's a different nature. We don't have, for example, very big forests. There are forests. We have forests, but they're not really, you know, the big European forest you're with, because the climate here is more tropical, so they don't have as much water. It doesn't rain as much in Greece. So it's a different environment. It's a very different kind of environment than if you come from Northern Europe or Canada, I think. You're going to see many different things here. But you're going to find also less things that want to kill you. Even the bears here are pretty shy, so... I think the only thing that's dangerous in Greece is we have one snake, it's called viper, a Greek viper, which is, it's kind of dangerous, but I don't think it kills people. I never had anyone killed by it. But it has a danger poison, and we also have bears, but you're rarely going to find them. They are back, northern Greece, and they're pretty shy, generally. They don't like humans so much. And the most dangerous things is actually white hogs. We do have a lot of white hogs, and I think Italy actually has a bigger problem than us. And those things are vicious, yeah. Those things will attack anything. So yeah, we don't have moose or goose. I actually hear goose is the most dangerous things in Canada, right? The goose are supposed to be very aggressive. Adding evaluators and heuristics to the code helps increase the quality, but it also makes generated content more predictable. Yeah. I hope to be pleasantly surprised by the generated content as possible. Yeah. Yeah, especially if you combine it with artificial intelligence. I don't know if... I don't know about what kind of artificial intelligence would work well. But yeah, this is one of the reasons why I'm using Python. So that's why I'm bothering with Python in the first place. Python has tons and tons of artificial intelligence libraries. It's by far the most popular language when it comes to artificial intelligence. Comes second, which is C++. But C++ is basically used to create the Python libraries in the first place. So the Python libraries are basically for performance reasons that are written in C++, and they are then ported to Python. So if you want to do AI, nowadays it's pretty difficult to avoid Python. So that means that I could use AI to control the generation of the rain, control the generation of the enemies. Of course, it's not going to be sophisticated AI because AI has a huge performance cost. But we can use like miniature AI that is not really that, and especially AI that runs on the GPU, which also something that Python libraries are using. They're using the GPU to learn the AI itself, which saves me the trouble of having to write the algorithms on the GPU, which is pretty painful. So yeah, I would definitely like to use AI for myself as well, for the terrain generation and for pretty much everything inside the game. To the extent that this, of course, is performance, right? Because performance is always going to be a big issue when it comes to artificial intelligence. Canada geese are not very nice, it's true. Okay. I've seen some videos, people get attacked. Actually, I've seen a video of a goose. I think it was in Canada. Yeah, I think it was Canada. That was it a seagull or was it an eagle? I think it was a seagull. That the seagull actually attacked its nest, the goose nest, and the goose hunt down the seagull and drowned him inside the lake. He attacked him until the seagull landed on the lake, and then he attacked him on the lake and put him in underwater and drowned him. I was like, what the hell? What the hell thing? So, okay, let's talk about now what I'm doing here. So for those that don't mess with the goose, yeah, indeed. So for those that don't really know what I'm working on, I'm working right now in many things. One of those things I'm working on is terrain generation. And I'm working on, let me show you, first of all, let me close that, because we don't need Python anymore, for now at least. I'm gonna come back to it when we need it. So let's go, marching cubes. Marching cubes, yeah, I'll go with marching cubes. So I was using, I think, this one. Low-level C++ compiled Python libraries probably offer the best Python words, Python friendliness, and C++. Well, for me, it's a trio. It's C++, Python, And in reality, also that applies also for the AI Python libraries. There are C++, there are Python, but also there are compute shaders, because usually AI and this kind of stuff, they run with computers. And this is actually what I'm going to do with the rate generation as well for the matching cubes. So what I'm using here is matching cubes, which allows you to take something that's voxelize it and then create geometry for it. So what it does, I don't think this is a... Let's take a look. What was it that it was showing how it does this? So what it does is that, let's say we want to create a procedural shape like this one. So this is just a shape in 2D, right? So what it does is divide it into voxels, which in this case are 2D voxels, so they are squares. So it divides to squares. And then the algorithm finds which of the vertices of those squares are inside the shape. And then it tries to find how far is the shape from the vertex. So it finds the exact area on the edge of the square where the face is. So it creates an average, creates interpolation. And creates the average that they exist there. And then it creates a shape that is the triangle mesh we create. So this is it converts this into triangles in essence, right? So this is, imagine that this is a mesh now, a 2D mesh. Now the next thing it does, it also goes through here and does an interpolation, which basically tries to put those vertices, the new vertices created. This is the old one, which is the voxel vertices, and this one are the new ones that generate for the mesh. It tries to put them as close as possible on the shape itself. So instead of having this mesh, which creates a lot of weird geometry, that it doesn't closely map to the mesh itself, we have this, which is a lot closer, which is, it still is an approximation, because look what happens here, for example. And we have this kind of close approximation. Now, this is going to be what I'm going to be using. What I'm already using, I've just found the corner trying to port it to Godot. And one of the things you can do is subdivide those cubes using what's called an octree. So the nice thing about this is that the octree doesn't just subdivide what you are used to 3D geometry. It doesn't just divide here. It usually concentrates the division around the areas of the surface. So that means that the new cubes we're going to create, the new voxels, which are going to be smaller, they're going to be concentrated around the area, which allows us to have something that's going to go a lot closer to the shape of the original geometry. So how we define this geometry? Well, this geometry is defined using size distance field. So it's defined procedurally. You can use simple shapes like spheres and cubes and cylinders, like we did with SDFs, which basically are basic mathematical equations that allows you to define shapes. You can also use images that can treat this as 2D or 3D geometry. So this could have been easily also an image. Because the only thing that the algorithm needs is to be able to something to tell it how close the vertex of the voxel is to the actual shape. So that's the only thing information. We need the distance of the vertex to the actual surface, which is the closest point of the surface, in order to be able to create the shape. Without the distance, we don't really know, how to create the geometry, obviously. So that's how the matching cubes algorithm works, and creates this kind of results, which are pretty blocky, but they can approximate any shape. And you can raise, of course, the resolution to make it more dense. So there are different techniques he uses here, like smoothing the normals and all this kind of stuff. Also, generating the normals is pretty easy using this technique, because we take derivatives, which are basically a way to subtract values from the z, y, and x-axis and see where those values change more rapidly, because we know that normals are always perpendicular to the surface, and because normals are perpendicular to the surface, anything that moves to that moves perpendicular to the surface always changes value most rapidly than anything else. So if you have this is the surface and you have something moving perpendicular to the surface, you have a rapid change of its value. If it moves parallel to the surface, you have no change in the distance, right? The distance remains the same. But here there is this distance changes really fast. Here the distance changes slower. So finding how fast the distance changes, we can find the normal of the surface, which makes things a lot easier, because otherwise, if we do it like how most meshes generate their normals, you have to go through every surface, calculate what edges it has, and trying to find, what the normal is perpendicular to the surface. So it's a bit more. I think it's a bit more expensive. Maybe I'm wrong there, but I think it's a bit more expensive to do it like that, or a bit more difficult. I don't know. Maybe. So we'll see. So right now I have found the code here. So this is what I'm aiming for. And of course, if you go to Marching Cubes Terrain, Marching Cubes Terrain, you can see some examples. I'm gonna mute that because I don't want to have a copyright thing with the music. So this is how Marching Cubes works from a terrain level, right? This is what we're aiming for, right? And the nice thing about Marching Cubes, because they are voxels, they use voxels, it allows us to create things like caves and overhangs, like things that have, because these things you cannot really create them with a height map. Usually terrains are created using height maps. You cannot really do those things with height maps. So that is what we are aiming for. So okay, let me first change the stream to say that we go for. Actually, I will take a small break. To rest my back a bit, and we'll be back in 10 minutes to work on Marching Cubes. So back we go to marching with cubes. So this is gonna be, actually no, this is a break. Okay, that's fine. Let's do it like that. Break. So see you guys in 10 minutes. Okay, I'm back. Okay, let's see. So this one is 125. Let's see, 126. 26, right? Yeah, 126. Back we go to the marching with cubes. So, okay, let's look at the chart. So with marching cubes, you can convert complex shapes into approximate simpler shapes. Yeah. Yes. To be precise, you can convert non-triangulated shapes, so things that are not already meshes, to a voxel format, and from there you can convert that voxel format to an actual mesh. So matching cubes is a way to make a mesh of something that exists in another format. So it's a way to create a mesh. It's a way to create triangle geometry. And that triangle geometry is usually approximation, which means it's definitely not going to have the original resolution of the mesh, unless, of course, you can have also a high resolution marching cubes pass, which means that you use a lot of voxels. It really depends how many voxels you're using. In this scenario, which I showed earlier on, it's easy to see. No, it's easy to see. Thank you for welcoming back. Thank you very much. It's easy to see the approximation because we have very low amount of squares, which they in 3D space they become. So this one is a marching squares technique. We are using a marching cubes technique because we do 3D. So the difference is the third dimension here. If I had like a crazy amount of detail on this grid, which is basically our voxels, so I had very small voxels, that approximation will be very close to the point that will be almost as close as the original. You wouldn't be able to see the difference with a naked eye. As a matter of fact, you can have one voxel per pixel. Probably you're gonna have more pixels per voxel because each voxel is capable of generating multiple triangles. So depending on the values it gets in the vertices, it's going to create in each side, each voxel will create those triangles to convert to the mesh. So you can have something like Unreal's nanite in Godot, where you can have an infinite resolution, so essentially, because the closer you get to the camera, the voxel size is defined by how close the voxel is to the camera, in essence. So that means you can have an infinite resolution mesh. You go closer, you see more detail. You go closer, you see more detail. Right? So the same way you do with nanite. Nanite actually uses voxels as well because I think it loads things to texture 3Ds, and usually texture 3Ds are for volumes. So I think probably they're using some kind of similar technique. One of the great things of using matching cubes also is because it allows you to dynamically generate the mesh geometry. That means you can also construct only what you see with the camera. So with Unreal Nanite, for example, you only if you see that hand, for example, here, is only going to draw the triangles for this side. It's not going to triangles inside here. It's not going to draw the triangles inside here. So what we call frustum culling, in essence, which basically takes the frustum of the camera. So it's basically the volume of the camera, how far the camera can see and how close. It's like a deformed cube, in essence, right? With a deformed cube with perspective size, with a perspective shape. And what is inside there is drawn, depending, of course, whether it looks to the camera or not, right? So what is behind that if the camera cannot see, is not going to draw at all. In this case, you can also have it not generate any form of geometry. But it still exists as an object, right? It still exists as a procedural geometry, at least, or some other form of geometry. You can use also textures or images. You can take images, for example, and use the matching cubes to generate geometry. Matching cubes are techniques that actually are used with images at first because they are used by medical imaging, which they take slices of patients and they have high resolution images for each slice, and then turn those slices to voxels because every pixel becomes a voxel. And then they actually matching cube with it every slice, and they create geometry in essence by making sure that our voxels are inside the gaps of those slices in essence, right? So they don't overlap with other size slices. So you can actually come up with, and this is exactly what he does here. In this one, that's what explains. So this one actually are medical images. The format for those are images. So I think the images are shown earlier on. What was it? That I think was an image. You cannot see it here. No, it doesn't show the image, but they are basically images. Now you can see here an example of a ray matching cube that has a much higher voxel count, voxel resolution. So you can see that now we've seen a lot more details here using this kind of technique. And of course you can make this more detailed, more detailed, more detailed. There's no limit to how resolution you can have. It's just when you have a lower resolution, usually matching cubes do not render the best geometry. They don't create the best geometry. There are other algorithms you can use, like dual contouring, and there's also transvoxel, there's also gigavoxel. There are like gazillion of different techniques that exist. And they are heavily used in games and in medical imaging. So there are techniques that are being used have been used for a long time now. So yeah, we're going to be using the most widely and most popular one, which is matching cubes. And then we're going to be moving to probably dual contouring, because dual contouring has the ability of doing better when it comes to edges. So you can see here, you cannot really easily see the edges. They are smoothed out between one figure and another. So this is one of the problems of matching cubes. It doesn't have as good resolution when it comes to sharp edges. So it does create resolution if you want, but it's not going to be as sharp, which means you have to increase the voxel resolution, which makes, of course, things much more expensive, because you tend up to create geometry that has a higher number of triangles. But also there's a sparse voxel tree that allows you to define areas of higher resolution and lower resolution. You're going to see that. I think there is an example here. No, I think probably was in this one. This one has adaptive resolution, for example. This one is actually using probably something like sparse voxel trees. So you can see here we have much more resolution for the hair and for the face, for the eyes, etc. But we have much lower resolution for the forehead that doesn't really need as many triangles. So you can actually control quite a lot of how you generate your geometry. So you can see here there is enough resolution to draw the geometry very effectively, compared to here that is going to appear much more blocky and much more triangulated to the eye of course, you have to imagine that this is going to be textured. So when you apply texture to a surface, the player will not be able to see the difference. And also another thing you can do is that you're not going to waste your time doing wrinkles, etc. with geometry. You're going to use a normal map. So normal maps also hide a lot of lack of detail in a model, so you can use normal maps as well to augment that. So there are different ways you can do to make this look a lot cleaner and a lot more detailed, if that's your my goal. But my game here is not to make very high resolution messes. I don't really care. I want to make something that's going to be easy to load and easy to process. So that's what I'm doing. This is the code I'm using from here, and we have ported this in my Godot module. And yeah, let's get started with it. Do I have... yes, okay. So let's go back to it. Where is it? Yeah, this one, no. So let's go back to the matching cubes. Let's go with the header file first that I was looking at. So this is the grid cell. This is how we define the voxels. It has... This is one... okay, so you may ask yourself, what the hell, why it's a 8? Well, because voxel has, of course, 8 vertices. There are obviously 2 squares that, whether you go top and bottom or back and front, and you can have a total of 8 vertices that define 6 faces, 6 how you call this? Not, yeah, 6 sides. 6 sides. And I think it's 12 edges total. And of course you have, for 6 sides, you have 2 triangles per side, which is of course 12 triangles per cube, because voxel is a cube in essence, it's a 3D cube. So these 8 vertices are storing their positions. So by using the position, we also know the general position of the voxel. And each of those things, so this is a location basically. So this is the location of each vertex, and this is the values they get. So those values are nothing more than lengths that measure the distance between the surface. If they are below the surface, I think they are positive or they are negative. I'm not sure, either they're positive or negative. And whether above the surface there are the positive or negative. So I assume that when they're below the surface are negative, and the surface is basically in this case is of course the procedural geometry or the image geometry or whatever input we are using for defining the geometry to map our voxels. So those values are going to be very important because they get to decide what kind of triangles we're using, what the layout of the triangles, whether it's going to be a triangle like here and here, or here and here, right? So it creates the setup of the triangles that generates per voxel, but also the position of those triangles, right? The vertex of those positions. Where is the triangle going to be up? It's going to be a bit lower inside the voxel. So everything happens inside the voxel, right? The entire geometry is generated inside the voxel. So it has those 8 values that are used for doing this generation. And now we have here the grid, which passes, of course, an array of grid cells. So I think here, this one, if I'm not mistaken, is per voxel. So this one stores only a single voxel. It's not an array, if I'm not mistaken. So I think the polygonize works per voxel and not on the entire voxel structure. The tree mesh face is going to generate the triangles for that specific voxel. The new vertex count, I think that is basically... I don't know what the new vertex count does exactly, to tell you the truth. And the vertices, of course, are the vertices that generates for those triangles. I think the vertex count probably is the vertex count for those triangles. Because you're not going to always generate the same amount of triangles, right? It depends on the values of those vertices of the voxel, whether you're going to generate 1, 2, 3, 4, 10 triangles, for example. So usually you generate, I think, up to 5 triangles, if I'm not mistaken. Yeah, I think it generates up to 5 triangles inside the voxel. And it really depends how many vertices, it depends, of course, the values of the vertices of the voxel, but also depends on how many vertices of the voxel are inside the surface. Because every time you put something inside the surface. If none of the vertices are inside the surface, of course, the voxel is completely ignored and it's not polygonized because it's considered to occupy empty space. So that is the code that we're using here. So basically what we're using here is an array that has the setup. So it says us which vertices are inside and which are vertices outside. So every of those combinations we can have take a different ID. So this is like an ID to be able to identify which scenario applies here. And using this scenario, this ID knows immediately by knowing the index of the scenario, which is going to be, let's say that this is the 10th scenario. So if it detects that's the 10th scenario, it's going to go and find the triangle table, which contains all the tables. It's a table that contains all the triangles per voxel that created, and say, okay, give me the 10th scenario. And the 10th scenario is going to go, let's say it's this one. So here, the -1 means this is the end. There are no other triangles to draw here. And it's going to draw a triangle that is 4, 1, 9. So this is actually the vertices. So it's at the index of the vertex. So it's going to find the index that is in the position 4 on the array. You have an array of vertices in essence. So you're going to find which one is the 4th vertex, this one, which one is the 1st vertex, this one, and which is the 9th vertex. And you're going to join them together into the index array, and this is going to form one triangle. Wait, one triangle. This one is going to form another triangle. This one is going to form another triangle. So here we have 3 triangles. And then it says, no, I have no more triangles to generate for that voxel. So this is the scenario for that voxel. That's how it actually generates the geometry. So how you calculate the scenarios are calculated here. So here it calculates which scenario is, and it gets that by taking the value of each vertex. I think it does a bitwise operation and finds exactly which scenario it should be applied in this case. So it does a bitwise operation, which basically plays with bits. It turns everything to a binary code and plays, and it's like a Boolean operation, right? How you do Booleans with 3D objects, you can do Booleans with values as well, and binary values, and that allows you to come up with some masking, extracting, and subtracting, techniques that bitwise operation uses. I'm not going to explain them because I also don't fully understand them, but I understand the basis, but it's not really important. The important thing is here that actually finds which cube index, which scenario applies in this case for generating the triangles. And once it knows which scenario is, of course, it uses that to go to the edge table and find the exact triangles it has to generate. So that's exactly what it does here. It goes through, let me see, it goes through everything. What is the cubing this? I don't know what this is though. Find the verses where the first get the shape of the cube. So here it takes the edge table. So this one gives us the edge. So there it does an interpolation, which is going to give it the value between what we did earlier on, basically. This interpolation here, right? So, where was it? This one. I think it does this interpolation here, if I'm not mistaken. Either it does this interpolation or this one. I think this is this one, though. I'm not sure, but I don't understand how this works. This is a Boolean. This is also a bitwise operation. Why does a bitwise operation into the entire? What? But this one returns an array. I don't understand. This one returns an array. So this one returns an array like this. So one thing I didn't say is that the scenario of 0 and 0 is for the empty space, is when everything is inside. So that means the voxel occupies empty space. And everything is outside, again, occupies. So these scenarios, we reject them because we don't create geometry for the scenarios, for empty space. Alligator Jazz. Hello, hello. I heard Python in Godot and click immediately. Welcome, welcome. Yeah, well, unfortunately, we actually, you came a bit late because we managed to integrate Python into Godot. So, but we definitely will be doing more Python with Godot because that's going to be a main language I will be using with my project. So you're going to see a lot of Python in the future streams anyway, most likely. But you're also going to be looking at a lot of C++ code, which we're doing right now. So yeah, Python works inside Godot, so yes. Still a lot of work to be done, of course, to make it access the internals of Godot, because get Python to work with Godot was easy. Getting to access the internals of Godot is going to be a bit more challenging. It's not going to be more challenging, it will be more challenging most likely, but it's also going to be a lot more work. But for that, there's no rush. We will take that step by step. So the one thing I will ask here is why the hell it does a bitwise operation on the entire array? What the hell? What is that? Now that I don't understand. Wait a second, first of all. It's 1, 2, 4, 8. Why it goes double there? So it goes through. Is it possible to access the array? Is it possible to access the array through a bitwise operation? So basically what a bitwise operation is, to give you an example, let me give you an example to understand what a bitwise operation is. Let's say a simple operation. So we have like a number 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 1. Actually, let's make it a bit more simple. 0, 1, 0, 0. And we have another number, 1, 0, 1, 0. And we want to do an AND operation, an AND bitwise operation. What happens is going to go through everything and going to go compare. It works basically similar to how Blender, you can do Booleans in Blender. So what you do here, it says, okay, what happens if I take 0 and add and do an AND operation on 0? So basically, the AND says that only when two things are true, they're going to be true. Only when two things are true, you're going to return true. So what happens here is going to say that, so 0 is false and 1 is true in this case, right? So it doesn't matter, it's a binary operation, 0 and 1. So it's false, false, it gives us false. So the number we're going to be getting here is going to be 0. Let's see, 0. So this one's going to give us 0. If true and true, this is the only scenario where it returns true for the AND operation. So this is true. If true and false, because it needs both of them to be true, it returns also false. And if it's false true, because it needs both of them to be true, it also needs false. So this one is going to basically change that into results in this new number, which is going to be a bitwise operation that has performed on these two numbers. So generally speaking, if you want to make those numbers into decimals, what you're going to say is that go in the power of 2. So the first one, I think, is 1. I can sometimes understand programming when I read it, but this is way beyond me. Hopefully I will pick more as we continue this project. Yeah, I mean, bitwise operations are a bit advanced, right? So have you done Boolean operators or in Blender, or have you done Boolean objects or constructing solid geometry, as they call it sometimes? So you can subtract or you can union things together. So a bitwise operation is a union, think it as a union. An OR operation is, I think, like a subtraction or a difference. I think it's a difference. So that's how it works, right? So you basically use to combine and change the shape of numbers, in essence, to make new numbers out of that. And there are many reasons you do that. So this one is going to translate to a number. It's called, I think it's, the first one is the power of 2. So this one is the power of 2. It's going to give us 1. The first one is also 1. Then it's the 2. And then it's 4. So this one's going to give us a number of 6, if I'm not mistaken, right? Am I right? Let's take a look at this. Let's see if my binary is correct. Binary to deck. Binary to deck. Let's see. Okay. So is this a 6? 0, 1, 1, 0. Okay. 0, 1, 1, 0. Convert. Yeah, it's a 6. Whoa, I'm good. Okay, I remember correctly. Wow. So every bit, we call those bits, and if you remember, 8 bits make a byte, and 1 million bytes make a megabyte, 1 billion bytes makes a gigabyte, etc., etc. So this is a bit, right? This is a 4-bit number, and it goes in the power of, the first one is 1, and then it goes to the power of 2, 1 into 2, 2, 4, 6, and if you continue, it's 12, 32, 64, 128, 256, 512, 1024, 2048, 4096, etc. So if you ever wonder why the hell textures have to be 496 or they have to be in the power of 2, this is the reason. Because they're using a binary address space, and by using, making, you actually fit the texture exactly in the memory that can, it knows now, okay, it's a 496, I know exactly how large it's going to be. Because it uses a binary space, so the maximum value you can have with that amount of bits is going to be 4096. So this is one of the reasons why textures have to be in the power of 2 in essence, because they're using a binary address space, and that's the reason there. This one is going to be 2, no 4 here, so it says 0, 4 is 0, and this one is going to be 8, so this one should be 10, right? Let's see if I'm correct, 10. So if we add 6, 10, what we have? Is this a 10? Let's see. 10, 10. Is this a 10? 10, 10. So let's see if I'm correct again. Yeah, so I'm correct again. Wow, I'm impressed. So this one is going to give us a 0, 0, 10, which is 0, 0, 10 basically is equals to, of course, 2. Because it's in the power of 2, so this one is a 1 always, the first bit is 1, and then is the power of 2, so power of 2 in the power of 1, because the first bit is, of course, 2, 2 in the power of 2 is going to be, of course, 4, 2 in the power of 3 is 2 multiplied by 2 by 2, yeah, it's 8, and so forth, right? So you always multiply by 2 in essence. So that's how bit-wise and how binary code really works. So this one is going to give us 6, 10, is going to give us a result of 2. So the big question here is how the hell this works here. Because now you said Fahrenheit, you don't understand how math works, but now I don't understand how this piece of code here works. So this piece of code here works how? Numbers, my old bitter enemy. It's you know, you learn those things. Like you learn everything else. The problem with mathematics is that it's pretty complex, to be fair, right? It's not a walk in the park. You have to learn so many things. I've been doing this streaming for 2 months now. Yeah, October. I started from end of September, October, November, and on those 2 months were mostly me reading math in the stream. So yeah, it can be a pain. And we're gonna be reading a lot more math in the future as well. That's pretty much certain. If you do procedure generation like I do, mathematics is pretty much a must use. So why the hell it does an odd operation to an edge table? That makes any sense. So here it checks to see what? I think here it tries to extract the position. I don't understand what it's doing here. Why it does a body-wide operation? Why cannot access the vertex list immediately? Why it has to do the bitwise operation? Because what will make sense to me is actually go through, yeah, why not access it directly? Why you have to do an if condition there? So this one is going to return the array, but the array itself is not one value. This one should be done in a single value. How the hell it does that? Because this one's going to return an array edge table, right? Ah, wait, it's an edge table. Oh, it's a not try table. Ah, it's here that does. Oh my god. Okay, that was my bad. Okay, I was confused. Okay, it's an edge table. Okay, so it actually takes these values here. Okay, my bad. Okay, my bad. So what it does here, I think, it tries to locate which scenario applies. No. Why it needs to check that? So I think that it has encoded inside this value, because this is going to return those values here. So these values here encode essentially wait a second, because I'm confused. Okay, I think this is basically it finds which index from the cube dux to use. Okay, so this is the cube index, right? So it identifies which cube index is for those values that appear here for the voxels. And the other thing that it does here is trying to find, I think it's trying to find out whether a specific vertex is present inside the array. That's the only way I can understand that, because obviously that's what it does here. It says that if the vertex is really, if there is a vertex generated for a triangle, then tell me what vertex that is, what kind of position it has. I think that's how I understand this. Okay. So basically here it checks to see if that vertex exists, and then if it does exist inside the new triangles we create, then it actually creates a position for it, which is going to be an interpolation of the values of the voxel. So as we say here, that we use the values that we pass to the vertices of the voxel to do the interpolation, to find the new shape, the geometry that we're going to get the triangles for. And that's exactly what it does here. Interpolation takes the P0, P1, P0, P1. Okay, so it corresponds to the voxels. So H vertex. Okay, so it's one vertex, yeah, because if we take a look at this, what was it? I think I said somewhere, the visualization. It was a visualization. Anyway, I think maybe it was in the header file. In any case, that's how it does this. Okay, so anyway, it does this the way it does it. So then we have new vertex count. I don't understand what the new vertex count is exactly. So, new vertex count. What exactly is the new vertex count? So the new vertex count here must be, so these are actually outputs. So even though they're supposed to be, this is one of the weirdness of C++, right, and C in general, is that in C, you can have an output from return functions, right, which is what you expect if you ever worked in other programming languages, but you can also have output from your input, which is crazy. And the reason behind that is because you pass it pointers, so where to access variables in the memory, and you can actually go inside and put in values inside those variables, inside the function. So you can use those variables as output in essence. So you can turn input into output. Because the input here is not the actual values, it's basically where to find those values. So that's one of the weirdness of C++. It has this pointer mechanic that allows you to have outputs inside the arguments. So those actually are, even though they appear to be inputs, no, this is an input, this is an output, this is an output, and this is an output, and this one is an output. Now this basically says whether, I think the polygonize succeeded, failed, if I'm not mistaken. Well, this one is the triangles, this one is the new vertex count, I don't understand what this is, and this is the vertices. So we generate, of course, triangles. This is per voxel, I think. Although this is one voxel, it takes one voxel, which is the grid, and generates a triangle, generates an array of triangles, which is this one. And of course, those triangles have an array of vertices, which is all this one. So all those vertices are basically this here. Actually, no, this is the triangles here. So this is the values going to go to the triangles. The vertices is actually going to be the new positions that generates from here. So this is going to be, which is why it has a vertex list. I think the vertex list is going to be the vertices, if I'm not mistaken. New vertex list. So the only thing I don't understand is this part here yet. So what the local remap does here, I don't know. What the hell is a local remap? Why it needs a local remap? Okay, so here it adds a new vertex, obviously, to the new vertex list. We can see because we see the assignment. And it also seems this one is going to return us an I is going to return us a specific vertex index. So this one is returns this list, the trie table, it returns vertex indices, which is basically where to go to an array that has vertices and find which vertex applies to that. So this is going to return just an indice to a vertex array, which means that this is a vertex array. But why has a vertex count? Oh, I understand now. The vertex count is actually the index of the vertex. So this shouldn't be the new vertex count, it should be the new vertex index. And why needs a local repamp? So first of all, have we created a vertex array? We have a vertex array here in form of the vertex list. Yeah, I think I understand what it's trying to do now. It tries to wait. And how? So the vertex list. Okay, I think what it tries to do is tries to join the vertex list of a previous iteration of polygonize. So it tries to add the new faces to the existing geometry it had generated previously in another call of the polygonize. I think that's what it does here. It tries to iterate and start to add those triangles and vertices to the existing list that have been created before this call. Which is, I was wrong actually. This is not just an output, it's actually an input. is going to take some kind of variable that already has vertices and triangles, and will try to augment the new faces. I think that's what it tries to do here, if I'm not mistaken. This is why it still talks about new vertex list and new vertex count. And it goes back here, says triangle count back to 0, and triangles. So it goes through 3, and then returns the triangle count. It doesn't return whether they succeed or not, it returns the triangle count. So okay, so it basically tells you, yeah, that's even better. It returns to tell you how many triangles it has generated. So actually, let's put that here. Returned the amount of new triangles generated per voxel. Voxel, take only one voxel as input. So this is per one voxel. Which is the grid. I think it's a grid here. So determine the index on the index which to tell us which vertices are. So find the word the surface index with a cube. Check also that vertex exists. Create new vertex with interpolated positions of the relevant distance values of voxel vertices. So that's how I understand this. Let's do that again. So locally map here, I think it tries to add this to the existing. So yeah, because it doesn't check to see if this is empty. So it never checks this whether this is empty. So we have to assume that this is, since it doesn't check whether these things are empty, it may take also as input things that already exist and append to that list the new values. Okay. So the new vertex count here, I think, is the new index. Probably it's the new index. Probably the new vertex index. And then moves to the next index. I think this one is for move to next vertex index. Vertex, no, actually it's a vertex index. Vertex index. So I think that's how it works. But on one hand, how the hell how on earth? So the new vertex list is where defined, first of all. New vertex list. So the new vertex list is defined. New vertex list. Where is defined? Here it is. Okay, so it's not augmented. No. The new vertex list has only 12. 12. If it has only 12, it means that is individual. No, it's not augmented. But the vertices here are, so no, I don't think it adds them. It doesn't add them, no. It doesn't add them. It assigns them one by one. No, it doesn't add them. It doesn't append them. So I was wrong. It doesn't exist. Those are not inputs. Those are not outputs. Actually, they're inputs. They're outputs, but they're not. They're just the mesh that creates, the geometry that creates. Yeah, I don't see anything else. Okay. So that should take, for example, so basically what it does here is the triangles, the rock coloring map. I just see too many loops here that I don't know if all those are necessary. But anyway. So basically here what we have to do is to give it basically an array of, that's going to have an array for triangles, an array for a new vertex count and vertices. But the only thing we care about is the triangle and the vertices. We don't even care for the next vertex count because, you know, we can always size the arrays and see how many vertices there are. So I don't know why this is necessary, the new vertex count here. Is it used anywhere? Why it needs a new vertex count? Why? Where is the new vertex count? Is really... new vertex, it actually makes it to 0. So it actually sets it to 0 here. So that means that there is no value, that it doesn't take a previous value. If it makes it to 0, it means that it cleans up the value. Why then it needs to be passed a new vertex count, and if it doesn't use it? That's, I find, confusing. So we have here this as an input, but it never uses this input. It basically makes it a 0. Yeah, this is the new vertex count. So it makes this to a 0. It zeroes this out, and then it assigns its own value, which is basically here. And I think that should be the, well, it's either the amount of vertices or is the entice of the vertex, which is the same thing in essence. Okay. Anyway, I don't know. I'm not gonna understand this completely anyway, so it's a bit mind-blowing. So, okay, so we have this one. So basically what that is gonna do should normally take a voxel here grid, which is a single voxel, if I'm not mistaken. But in order to not be mistaken, let's take a look at the other code as well. There was a corner. Okay, which one is using this technique here? Okay, let's take a look. Which one exactly uses this? Control copy and see who is using this. No one is using this. Okay, that's a problem. No one is using this? Really? No one. Absolutely no one? They're only finding C matching groups? Okay, no, yeah, maybe a problem. No, it's not a problem. Is it a problem? Yeah, it is a problem because I haven't renamed those. Okay, yeah. So let's try to find in bug CPP. Because basically I renamed the files from CPP files, which is the standard extension for C++, to bug CPP because I didn't want them to be part of the Okay, I'm confused now. Wait, the only thing it takes is the new face count? What? Why doesn't... Oh, wait, yeah, of course, because it takes as an input. So we have here the face storage. So this one is the G, which is G is what? The grid cell. Push polygons. So that is pushing the polygons. Okay, let's go with this one. Rename that file and start working with this file. So this one is the back, the ISO surface. So let's rename that to, of course, CPP, so it actually can process it and see if you have any errors first of all. So let's find the errors first of all. ISO surface. So it's gonna need also the header file. The header file is where? Is this one. So you're gonna need the header file as well, which has all the definitions. Okay, so that should fix that. Right, so it still complains that it cannot find the ISO surface class. But that's not the problem. Let's see what else. You cannot find the make object here. I think make object there exists. No, I think that's actually bullshit. I don't know why it reports this error. It shouldn't be reporting this error. And why it has problem with the delete? What? I don't know. So actually, let's try to build this. Let's try to build this and see what errors we're gonna get. Scones. This is gonna now create errors from us, of course, to be expected. Let's see what errors we got. Yeah, no, it's their errors. Inclined main H. So it has a main H file that we need here. Okay, so let's take a look at the main H file. So the main H file can be found in the original folder I had. So open file and go coding and go to matching cubes. Matching cubes. It has to have a main H file here. And that's basically imports other things there. So I want to separate that from the main example because it uses a lot of files that I don't really need. I don't want to import every single file, just the things that I need. Okay, so let's remove this definition. So where's the import main? So this main it doesn't exist, remove it. But what I want to import is the header file, of course. So the header file for this is, of course, actually let me rename those as well. They have to remain at some point. Key ISO surface. Actually, for now, let's keep it aside. It's okay because I'm going to rename them anyway. I have to restructure the entire folders. ISO surface H. So that should import the header file. The ISO surface exists here, right? I have it exist. Oh, okay, my bad. So wait. Okay, let's rename that as well then. Header file. So now I should not have a problem. Right, so now it can find those. Now it complains that it cannot find the functions. Why? So we have the tree mesh here. Face. So this one is part of the header file. So first of all, let's take a look. All the header files have some kind of guards. Yeah, that's not a good thing. The header file should always come with some kind of guards. I don't know why it doesn't have a guard here. Yeah, let's add in a guard for it. Let me remember how the guard is working. It's like this. So basically those make sure that the header files are not included more than one time. Let's make one guard for every one of those. So this one is going to be what is it? Kai ISO surface. Let's do this Kai ISO surface. So that makes sure that the header is included only one single file in a source file, so it's not included multiple times without being necessary. So it should never be included multiple times, sorry. And we can have the same thing, copy that. This is the header, there was another header, I think? Yeah, it's a controller. So let's add another header as well, header guard here. And that's gonna be controller, Kai controller. We use capital letters here just to make sure that people understand that this one is supposed to be just the definition, or macro, they're called macro definitions. High controller, and allows us to define things. So basically what happens here, for those that don't really understand what the hell is going on, this is actually our macros, that macros in C++ are a way to manipulate your source code before you compile it. So this one is going to go and does stuff to the source code before its compilation of the executable. So in this case, we basically said do not include this code again inside the source file, because includes basically are copy-pasting the code you see there inside the source file. That's what they do. So let's go with and if. So that ends the if here, and that can be a bit of a problem. Yeah. So I don't know if I'm going to be using these files. I'm not quite certain yet. I have to extract them one by one. Okay. So this is important. Calculate gradient is important because I think this one gives us the normal. Yeah, it returns us back the normal. So that returns back the normal, and it takes the position of the vertex as. So this is important. This is a function we need. The issues approximate is something we need as well. Polygonized grids is here. This is the push polygons. I think this one is responsible for adding together things and making the entire mess. So you use the polygonize to generate every face, but it calls it only one time. So it takes a single grid here. So which one is called the push polygons then? Push polygons is here called. But still, it's not. It is a for. Polygonized grids. What the hell is the top value and bottom value? So this one is go through every single voxel. And I think it separates the values, top values to bottom values. Okay. Yeah, it seems I have to read a lot of code to understand what's going on here. It's not that simple. It's not a walk in the park. Yeah, I will have to dedicate this time to start understanding this code, because if I don't understand it, I cannot make it work with Godot. So we have to see how those things work exactly. We have to go through one line of a code at a time and find exactly how it works. We add comments because it has no comments, so there's no way to know exactly what happens. So the ISO surface here is the procedural surface. We define procedurally. Usually, they are defined usually using science distance fields and all this kind of stuff. So you can, in the cave of terrain, of course you generate everything procedurally. You don't have an existing mess, right? So it doesn't make sense. Which is why it makes this technique very flexible. You can create procedural meshes using science distance fields. And if you remember the first time I worked with science distance fields, I said that if rendering the science distance fields is going to be very heavy performance-wise, that I will actually resort to converting the SDFs to triangles. And that's exactly what the matching cubes does here. It allows us to take an SDF, a science distance field, which we saw earlier. For those that don't really know what this is, it's basically the balls I saw that unite in the merge together. So you do Boolean but it has infinite resolution. And then convert to the finest resolution, which is the voxels, and then make a mess out of that. So that's how we're going to do those things. We're going to define the terrain using SDFs, in essence, and probably noises and 3D noises and all this kind of stuff. And then we're going to use this library here to generate the triangles for us to generate the actual terrain as a surface, as a mesh surface. So yeah, I will take a break to rest my brain that right now hurts from all this reading of code. And I come back. It seems that we have to spend several streams to understand how the marching cubes code works. And the irony of this is that probably I will not be using marching cubes in the long run. Probably I will use the dual codering because dual codering appears to be more efficient. But for now, because it's supposed marching cubes supposed to be easier for mesh generation, I will have to spend the time understanding the easy part and then go to something more complex. So yeah, I have to take a break for 10 minutes and then I will come back and continue reading the code. See you guys in 10 minutes. Actually, let me put that we're gonna take a break right now. Let me save that and let's go for a break. Oh, Fahrenheit, you're still here? I thought that you would fall asleep by now. You're still here. What are you doing here? Why you torture yourself with code and mathematics? Okay. So, okay, let's take a break for 10 minutes and be back. See you guys in 10. I'm back. I'm back. So I'm frustrated with my own project, so I have come here to watch you get frustrated instead. Ha! That's not nice. That's not nice. How are you doing this? Make me suffer like this? You want to watch me suffer and bleed? Yeah, I mean, part of coding is that suffering. Suffering is part of the deal, I'm afraid. And there's going to be a lot of frustration and there's a lot of pain. The frustration gets a bit easier the more you are doing coding. You learn to be patient and that you get stuck again and again and again. So getting stuck is basically, yeah, it's part of coding experience. But you learn, you learn to live with it. It's not a big problem. Same. You're frustrated with your own project, Harmony? Harmony, what project you're working on? This is the way, indeed. 3D World in Unreal Engine 5. Who is doing 3D World in Unreal Engine 5? A 3D World in Unreal Engine 5. So I think we're doing a pretty similar games. All of us here. We're doing games that are definitely involve a lot of procedural generation, from the looks of it. So we are gonna suffer. The feeling of success. Welcome back, Elons. Thank you for welcoming back. The feeling of success is so addicting. Yeah. You haven't. I didn't think you were here when I was jumping from joy for embedding Python to Godot. Yeah, that was me jumping from joy. Yeah, because it took me several days to do that. But yeah. Oh, come on, seriously. The bots have to. I have to find a way to ban those bots. What? Ah, it's V. Okay. Yep. What? Ah. Well. Okay, it's gone. So how to achieve many NPCs on screen in Unreal 4, in Unreal Engine 4. Watch Fahrenheit stream and subscribe. Nice. Thanks, Omoni. I have some ideas, but I haven't experimented yet. I will keep you in the loop. I do tanks in Unity, 3D, procedural content as well. Early stage, no streaming at the moment. Yeah, well, the thing I want to get to, the one thing I want to do here with what I'm making is the terrain generation. Of course, procedural terrain generation is pretty standard when it comes to space games, because my game will be also pretty much a space game. But also going to be you being on the planet. I would like to save the planet. But I would like also, I'm thinking how to use this for making also characters. So one of the things we can do is create 3D tools inside the game that allows you to generate voxel-like geometry that is animatable. So that is the only thing. Now there are ways to do this. We can use existing skeletal meshes and skeletons and base meshes, and then attach voxelized geometry on top of those pieces, and use the Godot to do the animation. It's going to be a standard animation from Blender, for example. Or you can do the entire animation with using voxels, which is going to be a lot more complicated because you have then to invent a new way of doing inverse kinematics, bones, bone weights, etc. So that is going to be a bit more complicated. But I think I will go for the first option, which is much simpler. Yeah. Tried to create 30-50 animated actors a few years ago. FPS was like 5. Voxel-like animated geometry sounds hard. Any shaders-based animations? Running animation on the shader, I don't know. Because a shader makes sense only if you do a ton of calculations the same calculations a ton of times at the same time. So you have like threads that are in the hundreds. If what you do is just 1, 2, 3, 4, 5, 10 threads, then a shader will not help you there. As a matter of fact, the shader will be a lot slower than a CPU. So animations, I think they're done on the CPU side. When it comes to the physics of the animation, right? How much the bone stretches and how you rotate a bone. Because usually you have like a few bones, right? You do the animation on. If you're talking about the actual change of the position of the vertex, yeah, you can do those on the vertex shader, essentially. You can have a vertex shader that is doing that, but you still have to do the physics for the bone. So the actual animation of the bones themselves, I think they will be done on the CPU side. I don't think they happen on the shader side. Speaking about shaders, we definitely will be porting this code to compute shaders, but then I first want to see it work on a C++ side. And what I've seen, you don't even need compute shaders to run matching cubes. They tend not to be that expensive if you don't have a huge amount of geometry. But if you move this into compute shaders, obviously we're going to make things a lot faster for us, maybe even 100 times faster, which also going to allow us to have a crazy large resolutions or a crazy amount of geometry. So yeah, there are definitely a lot of things to consider. When spawning 100 to 500 NPCs, there is a way called backing animation into a shader. Backing animation into a shader. Maybe if it means backing animation to shader, maybe it means baking. Baking. Okay, so it must be baking animation to a shader as a texture, maybe. Yeah. As a texture. Yeah, if it's a texture, yeah, because yeah, and we can do also the same thing with the terrain. You can bake the terrain to a texture because you can bake voxels to textures, but 3D textures. Which basically 3D textures are general textures that are an array of textures, an array of 2D textures. So there's no difference there. So you can definitely do that. As a matter of fact, 3D textures are used by Unreal Nanite as well. So yeah, you can bake pretty much everything. Scorpion. Hello, welcome. If you are like 2 minutes earlier, you were able to ban the bot. Baking animation, is that comparable to making sprites or so? Well, a sprite is nothing more than a collection of voxels. And in this case, the voxels are the pixels. So yeah. You can make 2D things with voxels as well. So you can make sprites with voxels. Most people know voxels because of Minecraft, but there's nothing stopping you from using voxels for... voxel is used also for smoke. Voxel can be used also for fluids. And voxel can be used also for sprites as well, yeah. Well, in sprites, in 3D sprites book in a way. No, not even 3D. You're talking about voxels that are completely 2D. Because you ignore, if you take a voxel and you ignore the z-axis, for example, you have a 2D voxel. Or in this case, you have a square, right? That's we saw with the margin squares that I saw earlier on. So you don't have even to go for 3D sprite. You can go for 2D sprite, or you can go for 2D pixel in essence. But you also can have 3D pixels. Voxels you can do anything you want, right? They can be 3-dimensional, they can be 2-dimensional, they can be monodimensional, 4th-dimensional. It doesn't matter, right? It's completely up to you. A voxel is definitely nothing more than a definition of space. So the space can be, of course, in any dimension you want it. It can be multidimensional. Even a line is a space, right? Because it has a length in essence, it has a 1 dimension. Then you have a square or a sprite that's 2-dimensional, they have 3D space, 3D objects, 3-dimensional, or then you have 4-dimensional when you have something that changes, with a 4th dimension being time, for example. 5-dimensional if you have some other value you want to calculate as well, like which level it is, or how powerful the sprite is, so it changes different colors. You know, all those are nothing more than designs you come up with, and you implement your own way of doing voxels in essence. Most people think voxels as nothing Minecraft, but that's not the only way to do voxels. You can do voxels in many different ways. Game Dev Unknown, shop, long time no see. Hello there, welcome. All the snails coming together after the rain. As a matter of fact, it was raining just right now, and my balcony is full with red dust, red mud, because apparently here in Greece we have the phenomenon called the red dust clouds, which basically are it's dust that comes from Africa. We call it African dust, and it comes from Sahara. So apparently, even though it has been raining and the temperature has been going lower, somehow Africa dust managed to come to my balcony. And now, well, not everything is red, but you can see red spots all around the balcony. It's kind of weird. I think this is the first time I've seen this happening during winter. Climate change for the win. Unfortunately, climate change makes the weather here in Greece crazier and crazier. Oh well. Welcome, man. How are you doing? Where you are? How the game? Do you do any kind of game? It has been a long time. Well, no, not a very long time though. But we are always glad to have you back. So welcome. So what I'm gonna go, guys, is I'm gonna go and say 0, 24, 43, 23. Let's say come back and I start ranting again, because you know me, I like to rant. Who doesn't? And 243, we're gonna go back to working and studying the marching cubes code. Studying code. That's fun. Haha. That red Sahara dust sometimes even reaches Germany. Wow, what the hell? Really? Together with rain called blood rain. Yeah. Yeah, it's like seeing spots of blood on the floor. Yeah, actually this is pretty true, because I heard that in the past it happened sometimes. Yeah, it happens here in Greece. It happens very frequently, actually. It happens very frequently, and usually during summer, in the start of the summer usually, or in the middle of the summer, we get some rain. Usually, yeah, it's blood rain, as you call it. So yeah, it makes everything. It's very exciting. It turns everything to red in everywhere, and it has become more and more frequently. It was pretty rare when I was young, but the last 10 years has become, unfortunately, much more frequently because of the climate, the way the climate is changing. Haha, nice. Currently, I'm working on a game called Godot kart racing. Oh, okay. Let's take a look at this. Let's take a look at this. Oh, okay. That's not bad. That's actually pretty good. Looks good. Nice. Nice, nice. I like what I'm saying here. Mario Kart, but with Godot characters. Actually, you know, I'm not a big fan of cartoony games in general. I always had a preference for more darker games and more detailed games. But Mario Kart is one of those things that I play a hell out of it. And one summer though, it lasted like 1 or 2 summers. That one friend of mine had it on their console, and it was a really fun game. It was back in 2000, I think, something. No, I think even earlier than that. So that's a nice game. It looks interesting. And I do always like the concept of Mario Karts. So, yeah. Nice. Well, it's nice to look something instead of looking at math and code all the time. So that's for certain. This is one of the things I'm annoyed with this stream, is that I have to do so much math and so much studying code that sometimes even I am bored with what I'm doing, right? I mean, I understand people getting bored and leaving the stream because, obviously, you know, seeing someone start just reading code for hours is not very exciting. But unfortunately, if you want to make a fully procedural game, especially when it comes to procedural geometry, you have to study a lot of math and a lot of code. That's no way around it. That's the sad part of this. It requires a ton of patience. But I'm okay, I'm not in a the goal is that I would like to have is by the end of December to have a basic voxel terrain generation. That will allow me to walk on a terrain, fly on a terrain, and, you know, obviously having a collision detection as well to be able to walk and be able to sculpt the terrain And if possible, also have some caves in this terrain to be able to navigate. If I can manage that until the end of December, I will be very, very happy. If not, well, okay. See you next year. So, yeah, Mario Kart is really fun. I played a lot. It looks cool. Yeah, it looks a lot cool. I played a lot the Super NES version, but it's more to Crash Team Racing than Mario Kart. Crash Team Racing? What is that? Is it Mario Crash Team Racing? You mean... Is it also Mario, this one? What's Crash Team Racing? I haven't really heard of that. Yes, you're right. In GKR game? What is that? GKR. Game... A lot of math is involved too. Not as many as yours, but damn, it gets harder, frustrating sometimes. Yeah. I mean, I do like studying the math though, because it allows you to do cool stuff. But yeah, it gets a bit tedious at times. So actually, my first console was a Nintendo NES, not a Super NES. I thought it was a SNES, but apparently it was a NES. Got back in 90 something. And I always wanted to get a Mega Drive, which I think is called Saturn in America, something like that. So it's the Sega system at the time. I always wanted to play. I didn't like. I like Mario, but not as much as I like Sonic. But yeah. Any PS4 owner here ever heard of the Dreams App game? Yeah. Dreams App, yeah. I heard of it because they're using also Science Distance Field as things. And they do something similar. They actually doing something similar I want to do, yeah. And I've actually watched they have a lot of streams that explain the technology, which I mean to actually rewatch now. I used to watch it in like a year ago because I was mildly interested in making a game that's procedural, but I was too afraid to do it. Now I'm definitely going to go back and watch them. They have some very interesting technology, yeah, for procedure generation, and they use something very similar to Science Distance Fields. I think they use Science Distance Fields, if I'm not mistaken. It's some kind of game level editor on the PlayStation. No coding necessary, but I guess there are some limitations too. But it looks yeah. My goal will be to go to the opposite direction. Allow you to make things without coding, but I probably will make Python the first citizen. So you have the Python API, which will allow you as a player to do crazy stuff and create crazy modification to the game. Also, GKR is Godot Kart Race. Okay, it's Godot. It's the name of the game. Okay. Never played Crash Team Racing from PS1. Crash Team Racing. Mario Kart, I don't know. Crash Team Racing, no. I don't know. Is it with Mario? I don't know. I don't remember the names. I know it's mainly because a guy was doing Avatar the Legend of Aang on it from zero open world. What is that? Avatar the Legend of Aang from zero open world. I don't know. Let's take a look at this. I said I'm gonna study code. I promise I will study code. Don't pressure me. Whoa, okay. Avatar the Last Airbender. Okay. So that's some kind of manga. I have to watch the movie Avatar, which I really liked. But I haven't know what that is. Is it a game? So it must be some kind of game, right? Avatar, The Legend of Aang. It doesn't really tell me anything. PS4, you say? Or PS5? It must be a PS2 game. So that's in a PS2 game. Okay. So let's take a look at this. What is that? Let's make sure that everything is quiet. Yeah. That's a Greek. League of Legends. No. What is that? Yeah, this is the game on PS2. Let's see, what kind of game is it? It's a nice animation. It has cell shader stuff, right? That looks pretty good. For PS2 game, that looks really good. I like it. It's like a, yeah, it's like a Prince of Persia thing. Prince of Persia, Sands of Time. Was it? I think it was, yeah. Prince of Persia, Sands of Time was one of my favorite ones. I actually love that. Really great game. Avatar the Last Airbender is the series. Not to be considered as the movie. Yeah. So I have watched the movie The Last Airbender. I haven't watched the manga because I'm not a fan of manga. I kind of like some manga, but yeah, usually I don't like the exaggerated screaming and crying and all the drama. So I like the manga that is usually a bit more toned down. So one of my favorite mangas is Ghost in the Shell. I was a huge fan. I'm still a huge fan of Ghost in the Shell. It was a great manga. And as a kid, I watched Nausicaa, I think called, from I think Gimli Studio, which was also loved that as well. But generally, I don't watch manga easily unless it's really toned down. No, it's a nice game. It's really nice. I like it. I like it. Damn, played Sands of Time a lot. Yeah, Sands of Time was really great. Prince of Persia. Usually, you know, you take a look at sequels and they kind of suck, but this one was a very good game. And even the movie was pretty good. There was also a movie. Was pretty good. I know that the movie didn't do very well, but personally I liked the movie. It was pretty nice. Benefit of more cartoony games is that you can get away with simpler, more stylized graphics. I think it really depends what you're trying to do, really. You know, take a look at No Man's Sky. It doesn't use cartoony graphics per se, but it doesn't have a lot of detail. Even the terrain doesn't have a lot of detail. The plants don't have a lot of detail. You can get away with anything. I think it's all about artistic direction. Not exactly benefit. Snowy Sierra. Did I see you here before? Yeah, of course you are here. We were talking about Procedure. Okay, I forget my memories. Yeah, we were talking about Procedure Generation, of course. Yeah. Not exactly a manga, but set in the old Japan. Anybody knowing Ghost of Tsushima? I know Ghost of Tsushima. I haven't played it, but everybody was talking about it, so it's difficult not to know this game. From what I've seen, I wasn't impressed. It looks like a very good game, but didn't seem like my kind of game that will excite me. Let's look at this. What? I don't know. Okay, I have like a question here. So this is my latest game I'm trying to play. It's X4. I'm most likely play space games. I'm a space game guy. Nausicaa is a great movie, but it's not manga. Manga is a different kind of movie. What? Nausicaa is not manga? Why? Not too much screaming? And not too much crying? Okay, I don't know. If you say so. I thought that Nausicaa was one of the classic mangas. Like Akira. And Ghost in the Shell, of course. But I'm not a manga expert by any means. I had no idea how, you know, the whole thing works, so yeah. Descent. Free space. But is this the Descent I think it is? Descent. Descent. I know a game Descent from PC. Well, it's very old. I don't know if you're making it is a classic manga. Wait, you just said that. Okay, Snow Sierra says that it's a manga. Because you guys have the same color, I confused that it was the same one replying. Okay, so let's look at this. Descent Free Space. Ah, yeah, it's this one, is it? Ah, this one must be the sequel to Descent. Yeah, it's the one that you navigate through. Descent was a great game, also very good game. Nice space game. So let's go back to reading code. The manga is crazy, huge panels with lots of details, which is not crazy. The manga is crazy. I love Nasuka. I like the story, basically. I really like the story. Really nice. So what I'm gonna do with this? What time is it, first of all? Actually, I think I will end the stream here. So let me go to... Yeah, let me change the flags because I was supposed to work, but it didn't work at all. So let's remove that. Okay, let's discuss. Let's talk a bit. I think I'm gonna end the stream. I'm kind of hungry and I want to take a break, to tell you the truth. And you should sleep, yeah. Why you are here? Why? Thank you for being here, Fahrenheit. You definitely should go to sleep, and you have kept your good sleep, so you are well rested for your game. So thank you for coming and joining me. Thanks everybody for being here. Descent originally was set inside procedural tunnel system. It was a procedural tunnel system. I didn't know that. Thank you for the stream. That's my pleasure. I have to read a lot more code now. So the next stream, guys, I warn you, if you come to the next stream, there's gonna be a lot of code reading. So yeah, we have to do a lot of the tedious stuff, unfortunately. So yeah, thank you for being in the stream, Fahrenheit, as always. I hope I catch up one of your streams, probably later at tonight. Have a good sleep. Design originally was set inside procedural tunnel system. Inside panels, free space is in the free space. Oh, that means that's a very different game. That means that's a very different game. I'm really interested to see how it works. So I'm very curious now. I actually will, don't stop the stream, I will go and watch some gameplay for the game. That's very interesting. So, while in Russia we can call manga movies like Bleach. We call manga movies like Bleach. In Russia, we call manga movies like Bleach. Is it Bleach a manga movie, or you call manga movies Bleach? I'm confused. Drama, frozen moments, and Miyazaki makes different kind of movies. Okay, so you basically say that the Ghibli, is it Ghibli Studio? Ghibli Studio is doing manga differently. Yeah, I don't like the very exaggerated manga. I do like manga that's a bit more, I don't know, a bit more well thought. I also find the stories pretty stupid in many cases. That don't make any sense. So I tried to watch, I think it was Batman Ninja, which was a manga that people were highly recommended. I just, I couldn't. The story didn't make no sense to me. I mean, I didn't understand what's going on either. But yeah, there's some mangas that are very, very good. I mean, Akira was very good, obviously. Was a great manga. And I've seen also Godzilla, the recent Godzilla mangas from Netflix. Actually pretty good. I really like them. And Ultraman also, I used the new ones. They were pretty good. The animation, they use some kind of form of 3D animation, which is really great. It reads very well for the manga. So they're pretty good. There are some, in Netflix, at least the ones I've watched in Netflix, some of them I really like. See you next time. Thanks for streaming. Yeah, man. That was fun. Descent could maybe also be handcrafted tunnels, not sure. Yeah, I don't think they're procedural, because this game is really old. I mean, it could be procedural, obviously, but I think it will be pretty expensive for the original. I think the original invented a very efficient 3D portal engine. Okay, I mean, Bleach is a manga. Sorry for the spelling from the phone. Okay, yeah, if you tap for the phone, it's gonna be like that. You're gonna make mistakes. The phones are not a best. I remember I got even a tablet for using it for coding and all this kind of stuff, because you can connect your tablet with your computer and you can use your tablet as an extra monitor, so you can use them like fingers and use it as a mouse pointer to control the mouse pointer and this kind of stuff. Never used it because it's just much more convenient to use a keyboard and mouse. So yeah, so let's make a stream summary. and end the stream. So what time is it? 3:01. So yeah, I make all those stream summary for people that are watching the stream from YouTube. So what we have to accomplish in this so in this stream, we managed to accomplish the packaging of Python in a single folder. So now I'm actually using a single folder inside, together with the Python executable. So this is the Godot executable. And this is my Python folder, which contains both the library for Python that it uses for launching itself. So this is the executable code in essence that Python uses, which is 50% of functionality of Python. But another 50% of functionality, of course, is the standard library of Python, which we have put inside here. So everything now is enclosed in a single folder, including third-party libraries. So you can find here third-party libraries, in this case pip, scones, and setup tools. And of course, we're going to be installing a lot more Python libraries here because we're going to be using a lot of third-party libraries for Python, which is the whole reason why I use Python. And here I have also the standard library, which contains all the standard modules that Python has. Platform PDP, for example, is the Python debugger. Oh, okay, that wasn't a bad idea. And finally, it's my Cyclops Python API, which here I'm going to put all the Python code for my Python API. Of course, the Python API will be half of it will be C++, half of it will be Python code, which allows us to access Godot internals, but also access the things that I'm developing, like procedure generation terrain here. So we have done that. We have managed to create the paths that are needed to put them in a nice batch file. So for Windows, I will do the same thing. The only difference, you probably will have to make a Windows batch file. And now we are back to studying the procedural terrain generation, because I will be using Python as long as I'm developing the project. So Python is, of course, it's not my sole focus. My main focus right now is how to make the game itself. And of course, the most important part of the game is going to be the terrain, because the game will take place on planets. So we go back to studying the procedure generation of terrain using matching cubes, which is the code here. We try to add some comments, and we try now to study also the other files and slowly go through all the source code we have found and downloaded available to try to comment everything out and see how to take those functions and adjust them from Godot, because obviously Godot has to operate in a specific kind of way. So that's what we do. The next stream will be in 2.5 hours, most likely. And we're gonna go and do the boring things, which is have to go through the code line by line and study and see how it works. So let's see the chat. I think the original design event, the very efficient 3D portal engine. I'm not aware of this engine. I mean, Blitz is a manga. Sorry for spelling. That's fine. I think I read that. Controlling a spaceship with 360 degrees movement freedom using a flight stick and a flight paddles is awesome. Takes some getting used to, but after that it feels very powerful. Yeah. Descent, I played the original Descent, which was inside the tunnels, was a great game. I really like it. Parkan was an epic space game many years ago, made in Russia. Russia. Actually, talking about Russia, my favorite animation is Russian, and it's called The Third Planet, which is a crazy, abstract, surrealistic animation with, I think, a murder investigation on crazy planets with plants that are like mirrors. A sunflower plant that's made out of mirrors or something like that. Very, very surrealistic animation. And I love that. It was one of my favorite, it's my favorite animation that I ever watched, right? And it was also introduced me, I think it was the first time I heard Jean-Michel Jarre, it's one of my favorite musicians, because they used the Oxygen 2 music for the, and it was a great animation. I love that. I think Russians actually make very good animation. For what I heard, I've seen some other animation you have a very good animation industry. And I watched also some sci-fi movies as well. I watched Stalker, I think, which was pretty good. It was pretty interesting. But yeah, animation was, yeah. Alisa. Oh, Alisa is Russian? Space Rangers game, strategy or RPG in space. Haven't watched that. Alisa. I watched Alisa, was Alisa the Guardian Angel? Or is Alisa something else? I don't know, it's the movie of James Cameron he produced recently. Yeah, that movie was a bit, not that great. But it was an interesting story. I like the story. But the movie was a bit, pretty average. Booklev story, I don't know that. So, let's rate the channel. Let's see who's gonna be rating. Okay, no one is doing Godot right now. Twitch TV. USSR movie. Nice. I will definitely check it out. No one is doing Godot from my contacts. So I have Dev Spousus. And who is Cake77? Cake77. Who is this guy? 77. I don't remember this guy. So he's doing C++. As always, my... let's go Godot here. Okay. Nope. What happens? Why I'm the only one that streams this hour? I'm the only one that streams usually Godot. Oh yes, I know this guy. Yeah. No, I think I will go for Spousus because Spousus is doing Godot. Oh, actually, no, it doesn't do Godot. He's doing Unity. What do you think, guys? Let's go for Spousus. So start a raid. I think he's doing very interesting. This guy makes a space rim world. So for those that wanted to make a 3D rim world, he's not 3D or 2D, of course, but I think it's actually very interesting projects. So anyway, thanks guy for joining. I hope you have a good one. We're gonna take a break for 2.5 hours, and we'll be turning in 2.5 hours to do a stream on reading the code we're gonna focus on procedural terrain generation and the marching cubes code here. Yeah, and thanks everyone for watching, for being here. See you again later if you are around. Bye bye.